friends, welcome back to our channel Physics Tutorial. Today we are going to continue with the first chapter of plus 2 physics, that is electric charges and fields. In the last class we had already discussed electric charge, properties of electric charge, Coulomb's law, electric field lines, electric dipole, electric field due to a dipole along the axial line. Hope it is clear to you. Now we have to move to the next topic, that is also very important derivation, that is electric field due to a dipole along the equatorial line. Are you ready? Here we have to find the electric field due to a dipole along the equatorial line. So here we can consider a dipole. This is an electric dipole, that is plus q charge and minus q charge. Equal and opposite charges are there. They are separated by a small distance, that is 2a. The total distance is 2a, and from the center, so this will be a, and from center to minus q is also a. Okay. And here we have to consider a point P on the equatorial line of the dipole. So this is the dipole, and here we have to consider a point from the center to this point P, means from the center at a distance r we have to consider a point P on the equatorial line. So this point is taken as P. So here we have point P, and we have to find the electric field due to this dipole on this point. So for that, what we have to do, here we will place a test charge, that is a unit positive charge we have to place here, and we have to find the field due to this plus q and minus q charges. So first of all we can find these values, because the distance between this plus q and p we have to find, right? In the similar way we have to find the distance between minus q and this point p. Right, so how we can find? Here we have A and this distance is R, because this point P is at a distance R from the center of the dipole. So this O is the center of the dipole. Clear? Now how we can find this distance? This angle is theta and this is a right angle triangle. Right, this is the hypotenuse. So what will be this distance? Here this is A and this is R. We can apply Pythagoras theorem. So what we will get here? This will be yes, root of r square plus a square. Here also we are getting the same equation, right? Here this is a and this side is r. This is the hypotenuse here. So here also root of r square plus a square we will get. So this side is clear now, right? So we have the distance between plus q and p and minus q charge and p. Now we have to find the directions of electric field. For that we can consider the point p and plus q at first. So here we have a positive charge, and here we are placing a test charge, that is always a unit positive charge. So these two positive charges, they will, yes, similar charges will repel each other, right? So what we will get here, this charge will be repelled, means the direction of field will be like this. The direction is as shown here. Here we can see the direction E plus Q. Clear? So this is the direction of E plus Q. That means the electric field due to plus q charge, the direction is coming like this, that is outwards. Clear? Now in the similar way we have to find the direction of minus q charge also. Here we have a minus q charge and here we have a positive charge. So what we will get here, these two will be attracted. So here the direction of the field will be coming like this. Here we can see the arrow mark here. This is the direction. Here this is E minus q. Yes. So these two are the directions. E plus q is coming here and this is E minus q. Right. Here these two charges are equal and opposite charges. So they will attract each other. And now we have to find the resultant of these two. E plus q and E minus q. How we can find? Here we can see this E plus q, and how we can find the value of E plus q? That will be, we can resolve this into two components, rectangular components. So what we will get here, that along x-axis and along y-axis. So this is the resolution. So what will be this component? This is the cos component, that means the horizontal component. So E plus q cos theta is coming here, and this is E plus q sin theta. Clear? That means the horizontal component and the vertical component. In a similar way we have to resolve this component also, that is E minus q. So how we can resolve it? This is coming like this. So along the x direction and along y direction. So here this is cos component and this is sin component, right? This is the horizontal component E minus Q cos theta, and this is the vertical component E minus Q sin theta. Now we are getting the components of E plus Q and E minus Q. And now how we can add these? Here we can see this E plus Q sin theta and E minus Q sin theta are equal and opposite, because E plus Q and E minus Q are equal, right? So these two will be getting cancelled, and what is remaining here? This E plus Q cos theta and E minus Q cos theta is remaining here, right? So the total will be, that means the total electric field will be E plus Q cos theta and E minus Q cos theta, sum of E plus Q and E minus Q cos theta, right? So now we can start with the derivation. Hope it is clear to you, the diagram, because that is very important. Before starting the derivation, we have to draw this diagram. Here we have to find the magnitude of electric field at P due to plus Q charge and due to minus Q charge. So first of all, we can write the magnitude of electric field at P due to plus Q charge, that can be represented as E plus Q. So how we can write? E plus Q charge is 1 by 4 pi epsilon 0, that is the electric field, right? The equation for electric field is 1 by 4 pi epsilon 0 Q by R square, right? So here what is the charge? Here plus Q charge, so Q we can write, and what is the distance between plus Q and P, that is root of R square plus A square. So square of this we have to write. Okay, so E plus Q is 1 by 4 pi epsilon 0 Q by R square plus A square. Clear? This is first equation. And now the distance between minus Q and P is also R square plus A square. Okay, only the magnitude we are writing here. So E minus Q can also be written like this. So 1 by 4 pi epsilon 0 Q by R square plus A square. So that is the second equation. So here we are getting E plus Q and E minus Q. Now we have to find the total electric field. So how we can add the field together? Here we have to mention that the vertical components will get cancel each other. So these two components, vertical components, will get cancel each other. So only the horizontal components will be added. So what will be the total field? Total electric field is equal to E plus Q cos theta plus E minus Q cos theta. Clear? So E plus Q cos theta plus E minus Q cos theta. And we know that E plus Q is equal to E minus Q. Right. Then cos theta is common. So how we can add these two here? That will be 2 into E plus Q cos theta. Clear? Because this E plus Q is equal to E minus Q. So 2 E plus Q cos theta. That is the total electric field. And now we have to know what is cos theta. Cos theta we can find from this diagram, right? How we can find cos theta? Here we have A and here we have root of R square plus A square, and this side is R, and this angle is theta, right? Now can we take the cosine of this? So cos theta will be equal to adjacent side by hypotenuse. So A by root of R square plus A square, or we can write it as A by R square plus A square whole raised to 1 by 2. Instead of root, we can use this whole raised to half. Okay, so it is better to write as A by R square plus A square whole raised to 1 by 2. Now we can substitute in equation 3. So what we are getting is equal to 2 into E plus Q means, yes, 1 by 4 pi epsilon 0 Q by R square plus A square into cos theta means A by R square plus A square whole raised to 1 by 2. Now we can give some substitutions. Here we have 2QA. What is that? 2Q into A, or 2AQ, that is equal to dipole moment. Okay, so we can write P is equal to 2AQ. So instead of 2AQ we can substitute P. And here we have R square plus A square, and here R square plus A square whole raised to 1 by 2. This is just like A raised to M into A raised to N. So that will be A raised to M plus N, right? So what we will get? R square plus A square, the whole raised to 1 plus 1 by 2. That is whole raised to 3 by 2. So all these substitutions we can give here. So what we will get here is equal to, so instead of 2AQ we are giving P. So 1 by 4 pi epsilon 0 can be written in the similar way. So 1 by 4 pi epsilon 0 into P divided by, this is R square plus A square whole raised to 3 by 2. Clear? Now suppose we are having this R very much greater than A. R is very much greater than A means here this A can be neglected. So what we will get? P divided by R square the whole raised to 3 by 2 only will be remaining here. So this square and 2 and 2 will get cancelled. Then what will get? That is P by R cube. Right. So for R too much greater than A, the equation of electric field will be equal to E, that is equal to 1 by 4 pi epsilon 0 P by R cube. So that is the equation for finding the electric field due to a dipole along the equatorial line. Clear? Now we can have a quick review. Here we have to find the electric field due to a dipole along the equatorial line. So don't be confused with the axial line and equatorial line. Axial line will be along the axis. Okay, here we have a point in the equatorial line of the dipole. So this is the dipole and this is the equatorial point, and here we are taking the length of the dipole as 2a, and from the center to point P the distance is R. So at a distance R we are considering a point P, and here we have to find the electric field due to this plus Q charge and minus Q charge. Okay, for that first of all we are finding this third side. Here we have A and this is R. So this third side will be root of R square plus A square. Here also we are getting the same value. Okay, and what about the direction of the field? Here we have positive charge and this is also positive charge. Test charge is also positive charge. So this field will be away from this. Okay, so that will be E plus Q. The direction of E plus Q is outwards, and here we have minus Q charge and this is positive charge. So that will get attracted. So here we have the direction, that is E minus Q is coming here. Okay, it is attracting minus Q charge. And now we have to find the resultant of these two, E plus Q and E minus Q. Here we have E plus Q charge. So we can resolve it into two components, that is here horizontal component and this is vertical component, and here also E minus Q also can be resolved into two components, that is this is the horizontal component and this is the vertical component. So what happens is this vertical components will get cancelled and only the horizontal components will be added, that is E plus Q cos theta and E minus Q cos theta only will be added. The magnitude of electric field at P due to plus Q charge is 1 by 4 pi epsilon 0 Q by R square plus A square, because here Q by R square we are doing and here 1 by 4 pi epsilon 0 Q by R square plus A square. So the magnitude is same, right? E plus Q is equal to E minus Q. Then the total field will be E plus Q plus E minus Q. That will we have to add. So here we have E plus Q cos theta plus E minus Q cos theta. And cos theta is found to be A by R square plus A square whole raised to 1 by 2. Then we can substitute. So 2 into E plus Q is 1 by 4 pi epsilon 0 Q by R square plus A square into cos theta, that is A by R square plus A square whole raised to 1 by 2. Here 2AQ is equal to P, and this will come to be R square plus A square whole raised to 1 plus 1 by 2, that is whole raised to 3 by 2. So what is our equation? 1 by 4 pi epsilon 0 P divided by R square plus A square whole raised to 3 by 2, or for R very much greater than A we can write the equation E is equal to 1 by 4 pi epsilon 0 P by R cube. So this is the equation for finding the electric field due to a dipole along the equatorial line. Okay. We have completed both the derivations, that is the electric field due to a dipole along axial line and equatorial line. Now we have to find the relation connecting axial field and equatorial line of a dipole. So in the case of axial field we saw that E is equal to 1 by 4 pi epsilon 0 2P by R cube. That was the final equation in the case of axial field. Okay. And in equatorial field what was the final equation? Yes, that is 1 by 4 pi epsilon 0 P by R cube. Now we can connect these two, right? So what is the relation between axial field and equatorial field? That is 2 into equatorial field will be equal to axial field. Now we can say that in the case of axial field that will be equal to 2 into equatorial field. The next portion, that is dipole in a uniform external field. So dipole we have to place in a uniform electric field. So then what will happen? What is uniform electric field or uniform external field? When we are considering a region and there we consider an electric field, so what happens is that the intensity of electric field will be same throughout that region. Such a region is called uniform electric field. in such a uniform electric field, we are placing a dipole. So here we can see this is the direction of the electric field. Here throughout electric field is there, and we are placing a dipole on that field. So minus q charge is here, plus q charge is here. Then the distance between these two charges is 2a. So this is our dipole. We are just placing that dipole in a uniform external field. Then what is happening here? Suppose we are placing a charge on a electric field, what will happen? There will be a force acting on that, right? That is understood. So in which direction the force will act, that we should know. And what is the equation for finding the force? Actually, we have studied that electric field is equal to F by Q. Here F is the force. So from this we can find the force, right? What will be the force? F is equal to Q into E. We can cross multiply that. So F will be equal to Q into E. And the magnitude we have found now, right? And we have two charges, right? One is negative and the other one is positive. So in which direction the forces will be acting? That is our next problem. So you should know that when we are placing a positive charge, to which direction the force will be acting. So just understand, if you are taking a positive charge and it will experience a force in the same direction of electric field. Here we can see the direction of electric field is upwards like this. Okay. Then the positive charge also will act a force in the same direction of electric field. Here we can see that plus QE is the charge, means the force due to this plus Q charge, and it will be acting in this same direction of field. And in the case of negative charges, when we are placing it in a field or external field, we can see that that will be acting opposite to the direction of field. So here the direction of field is upwards, then the negative charge will be acting a force in the downward direction. Okay, so this is minus QE. So that is very important. Here we have minus QE and here we have plus QE, and these two are equal and opposite. They are acting on the same dipole. Then what will happen? Will there any net force acting on that? No, right? So these two will get cancelled, right? So the total force will be cancelled. But what about the torque? What is torque actually? Torque is one of the forces into perpendicular distance between them we can find. Easily we can do in this case. So suppose we are taking this. This is our dipole. Okay, these two ends are there and one side is positive and the other side is negative. And suppose this force is acting upwards and this is acting downwards. Okay, if the point of action of force is, or the line of action of force are different, then what will happen here? If the line of action of force are different, means both will be, this will be rotating like this, right? On this side the force is acting downwards and this side it is acting upwards, so that will be rotating. So in this case we can understand that the two forces are equal but the line of action of force are different. So there will be a torque acting on this. This will try to rotate. Okay, the force is only here, the force is acting, so that is upwards and this side is downwards. So this will be rotating like this, so that we can say that the total force will be 0 but the torque acting on it will be there. So what will be the magnitude of torque? So that we have to calculate. So torque we can calculate here by using the equation, one of the forces into perpendicular distance between them. So here any one force we can consider. Suppose we are taking this QE. QE is in this direction. Then we have to multiply it with the perpendicular distance. So here if it is like this, means the perpendicular distance will be coming here. Okay, so this is our dipole and we are finding this perpendicular distance. Here angle is theta. Then here 2a is the distance. Then what will be sine theta? Here we can find this length, right? So that will be 2a sine theta. So we can substitute that equation. So then what we will get, tau will be equal to QE into, QE is one of the forces. Force is QE. Only the magnitude we are taking. Then into perpendicular distance, that is 2a sine theta. So QE 2a sine theta. QE means that is force, right, into 2a. So we know that P will be equal to 2aq, right? 2a into q is P. So we can substitute for that. Then P into E sine theta we will get. Now P sine theta means we can write it as P cross E. As a cross product we can write. That means torque is equal to P cross E. Clear? So, that will be the torque acting when we are placing a dipole in a uniform external field. So, this equation is very important because that total force will be 0, but the torque will be tau is equal to P cross E. And suppose we are placing this in the same or opposite directions. Suppose P and E are in the same direction, then what will happen here? The angle between them will be 0, or if it is in the opposite direction, that will be 180 degree. Then what will be the torque acting on that? Tau is equal to P sin theta. Right, here if theta is equal to 0, what will happen? Sin 0 is 0, right? Or 180 degree means again that will be 0. So, torque will be 0 if P and E are in same or opposite direction. That is theta is equal to 0 degree or 180 degree. And suppose they are perpendicular, that is P and E are perpendicular means what will happen here? Theta will be 90 degree. So, sin 90 is 1. Then what we will get? We will get maximum torque when it is perpendicular. That means P and E are perpendicular. That will be equal to PE. That is the maximum torque acting on that. So, that is all about dipole in a uniform external field. Clear? Now, we can consider the dipole when it is placed in a non-uniform electric field. Then what will happen to that? Suppose we are taking a non-uniform electric field and we are placing a dipole in that. In such a case, the net force and torque on the dipole will not be 0. So, what happens is that that dipole will undergo translational and rotational motion. So, if we are placing such a dipole, then if P is parallel to E, that means dipole moment is parallel to electric field, then what happens is that the dipole has a net force in the direction of increasing field. Okay, so the net force will be in the direction of increasing field and torque will be 0 because tau will be equal to PE sin 0, then that will be equal to 0. And if it is placed in anti-parallel to electric field, that means when P is anti-parallel to E, what happens is that the net force on the dipole will be in the direction of decreasing electric field. Okay, decreasing field, that will be in the direction of decreasing field, and torque will be equal to P sin 180, that will be equal to 0. So, this point also you just understand. Now, we can move to the next topic. Our next topic is Gauss's law. So, before moving to Gauss's law, we have to understand some continuous charge distribution because that we have to use in Gauss's law. So, for understanding that concept, we can just see that what is continuous charge distribution. So, here there are three types of charge distributions. First one is linear charge density, then surface charge density and volume charge density. So, here in the case of linear charge density, that from the name itself we can understand that charge density. So, that means charge per unit length. Linear charge density is charge per unit length, that is lambda is equal to Q by L. So, in detail we will explain in Gauss's law, but you just understand this. Linear charge density means charge per unit length and that is represented as lambda. Lambda is equal to Q by L. And in the case of surface charge density, that is charge per unit area. Right, that is sigma is equal to Q by S. So, surface charge density is sigma, that is equal to charge Q by unit area, that is S, or A we can use. And then volume charge density, that is charge per unit volume, or rho is equal to Q by V. So, these are the three charge. Linear charge density, lambda is equal to Q by L, then surface charge density sigma is equal to Q by S, and volume charge density rho is equal to Q by V. So, this is all about this video. Hope it is clear to you. Now, we can conclude the video. So, in the next video, we can discuss Gauss's law and its applications. Thanks for watching.